Hello everyone. Today we will see how to compute n-point DFT of a given sequence and plot the magnitude and phase spectrum for the same by using the MATLAB software. First we'll see what is discrete Fourier transform, that is a DFT. So DFT, that is discrete Fourier transform, it is a powerful computation tool which allows us to evaluate the Fourier transform which is given by x into e raised to j omega on a digital computer or specially designed digital hardware. Now because x into e raised to j omega, it is a continuous and periodic function. The DFT is obtained by sampling one period of the Fourier transform at a finite number of frequency points. And apart from determining the frequency content of a signal, the DFT is also used to perform the linear filtering operations in the frequency domain. And the sequence of n complex numbers that ranges from x raised to 0 to x of 0 to x of n minus 1, it is transformed into sequence of n complex numbers again from x naught to x raised to x naught to x of n minus 1 by the DFT according to the formula x of k is equal to summation n is equal to 0 to n minus 1 x of n into e raised to minus j 2 pi divided by n into k into n, and here the range of values for k ranges from 0 to n minus 1. So here x of k, that is capital X of k, it represents the frequency domain representations, and e raised to minus j 2 pi into k into n divided by capital N, it is a complex exponential basis function, and n, that is the capital N here, it is the number of points in the DFT, therefore it is named as n-point DFT. These are some of the properties of DFT. That is, you have frequency shifting, linearity, time shifting, Parseval's theorem, symmetry, periodicity, convolution. So these are the properties of DFT. Now we will see how to calculate the DFT here. Suppose I am taking a 4-point DFT, therefore n is equal to 4. So I will take the sequence as x is equal to 2, 4, 6, 8. This is the 0th position, first, second and third. So it is 4-point DFT. This is a formula for our DFT. Now here I'll write it as x of k is equal to, so here it is n is equal to 0 to n minus 1. N is 4, therefore n minus 1 will be 3, and here the range will be 0 less than or equal to k less than or equal to 3. N minus 1 will be 4 minus 1, that is 3. Now here n is equal to 4. So we have to compute x of 0, x of 1, x of 2 and x of 3. That is, these all are capitals and these are small n's. This is x of 0, small x of 0, small x of 1 and so on up to small x of 3. Whereas we want to find out capital X of 0, x of 1, x of 2 and x of 3. So here first we will write x of k, that is capital X of k is equal to, okay, we will expand this formula and we will write the values for 0, n is equal to 0 to n is equal to 3. First it will take the form as, first here we will write x of 0, okay, x of 0 e raised to minus j 2 pi n by capital N k into, now n value is 0 we have taken, so 0, plus next the value for small n will be 1, so x of 1 e raised to minus j 2 pi by 4, why 4, n is equal to 4, k into 1, okay, now n is equal to 1. Then next plus x of 2 e raised to minus j 2 pi by 4 k into 2. Next we have to take x of 3 e raised to minus j 2 pi by 4 k into 3. Okay. Now this is what we have expanded for this formula by substituting the value of small n. So here we'll simplify this. X of k will be equal to x of 0. This term, it is multiplied by 0. So e raised to 0 will be 1. Therefore, this first term will be x of 0 only. X of 0 into 1 will be 1. Plus x of 1 e raised to, it will be 2 ones are 2 twos are, it gets cancelled. So you get here minus j pi by 2 into k. Okay, k into 1 is k. So you will get e raised to minus j pi by 2 into k. Next is x of 2 e raised to. So here 2 twos are 4, 4 gets cancelled. You get minus j pi k, e raised to minus j pi k. Next here x of 3 as it is. Then you have e raised to, okay, e raised to 2 ones are 2 twos are, it gets cancelled. So here you get minus j pi, okay, minus j 3 pi into k divided by 2. Fine. Now next we have to substitute the values for k and we have to find out the value for x of 0, x of 1, x of 2 and x of 3. So here we will substitute the values from 0 to 3. So now we have to put k is equal to 0, 1, 2, 3. For k is equal to 0. Here we have our expression which we have got in the previous slide. That is x of 0 is equal to, here now we have put x of k we want to find out now. So k is now 0. So capital X of 0 is equal to, this is small x of 0. Okay. Small x of 0 plus x of 1 e raised to minus 2 pi by minus j pi by 2 into k plus x of 2 e raised to minus j pi k plus x of 3 e raised to minus j 3 pi by 2 into k. Now here we have to substitute the value of k. Our value of k here is now 0. X of 0 will be as it is plus x of 1 into e raised to minus j pi by 2 into k. K is now 0. So this term becomes 0. E raised to 0 is 1. Okay. Next, third term, x of 2 as it is. Again k is 0. So this term, this will become 0. E raised to 0 is equal to 1. Plus x of 3 e raised to, k value is 0. So here again this term, it will become 0. E raised to 0 is 1. So x of 0 is what? What was our sequence? It was 2, 4, 6, 8. At 0th position we were having 2. Second we have 4 at first position. Then we have 6. So x of 1 is 4. X of 2 is 6. X of 3 is 8. You add it, you get 20. So now x of 0, capital X of 0 is 20. Next we have to go for k is equal to 1. Now you have to substitute k is equal to 1 in this equation. Okay. So x of 0 again it remains as it is. This is small x of 0. It is not capital X of 0. It is small x of 0 plus small x of 1 e raised to, k value is 1. Therefore it will become minus j pi by 2 plus x of 2 as it is, e raised to minus j pi. Now k is 1 plus x of 3 e raised to minus j 3 pi by 2. K is 1. So you will get minus j 3 pi by 2. Fine. Now x of 0 is 2 as it is, we'll write, plus x of 1 is 4. Now here this you have to expand. That is e raised to minus j pi by 2. It is in the form e raised to minus j theta, which can be expanded as cos theta minus j sin theta. Now what is the value of theta here? Your value of theta is pi by 2. So substitute this as pi by 2. Okay, use your calculator. Cos of pi by 2 minus j sin pi by 2. Here you will get it as minus j. Okay, similarly you have to do it for e raised to minus j pi and e raised to minus j 3 pi by So for this e raised to minus j pi by 2, you got it as minus I, that is minus j can be written as minus I. Then here e raised to minus j pi, for this you will get it as minus 1, you will get only the real term, you don't get the imaginary term. Then e raised to minus j 3 pi by 2, here you will get it as again I. Okay, now multiply this, simplify this. 2 plus into minus is minus 4i, plus into minus is minus, 6 into 1 is 6, plus 8 into I is 8i. So here you will be getting 2 minus 6 is minus 4, and minus 4 plus 8i is, you will get it as plus 4i. Okay, this is for k is equal to 1. Next we have for k is equal to 2. So for k is equal to 2, again you have to take the expression, same expression, and you have to substitute k is equal to 2. X of 0 remains as it is. X of 1 into e raised to minus j pi. K is 2 now. So 2 and 2 gets cancelled. You get only minus j pi plus x of 2 e raised to, again k is 2 here. Therefore you will get it as e raised to minus 2 j pi. Then plus, I should have written here minus j 2 pi plus x of 3 e raised to minus j 3 pi by 2 into 2. So 2 gets cancelled, you get minus j 3 pi. So again you have to expand this in the form of cos theta minus j sin theta, and you have to get the values for these by using your calc. So x of 0 is 2 minus x of 1 is 4. When you simplify this, e raised to minus j pi, you get it as 1 plus x of 2 is 6. E raised to minus j 2 pi, when you simplify, you get it as 1. X of 3 is 8. E raised to minus j 3 pi, it will be minus 1. So again simplify this, you will get it as minus 4. This is our capital X of 2. Now for k is equal to 3. Again take the same expression, substitute k is equal to 3. So x of 0 will be as it is. X of 0 first term same. X of 1 into e raised to. Now k is 3. So it will be minus j 3 pi by 2. K value is 3 now. We'll substitute k as 3. So we'll get it as minus j 3 pi by 2 plus x of 2 into e raised to minus j pi, k is 3. Therefore, we'll get it as minus j 3 pi plus x of 3 e raised to minus j, k is 3. So 3 into 3 will be 9. So you'll get minus j 9 by 2 into pi. Now again you simplify these all terms by using cos theta minus j sin theta. So you will get x of 0 is 2 plus x of 1 is 4. When you simplify this term, you will get it as I. Similarly, x of 2 is 6. When you simplify e raised to minus j 3 pi, you get it as minus 1 plus x of 3 is 8. E raised to minus j 9 pi by 2 is minus I. Simplify this, you get it as minus 4 minus 4i. Okay, so we will get capital X of k is 20. Okay, then you have minus 4 plus 4i. Then this is x of 0, capital X of 0, capital X of 1, capital X of 2, that is minus 4. Then capital X of 3, that is minus 4 minus 4i. Now you have to calculate the angle and magnitude for these by using your calculator. So when you solve for that using your calc, you get the magnitude for this will be, that is for 20 the magnitude is 20. For minus 4 plus 4i you will get it as 5.6569 as the magnitude. Then for minus 4 magnitude is plus 4, and for minus 4 minus 4i the magnitude is 5.6569. And angle, so for this angle is 0. For the second term the angle is 2.3562, this is in radians. And for minus 4 you have 3.1415. and for this last minus 4i you are having minus 2.356. Okay, so now how you calculate this in your calculator, I'll show you. Just see this. Today we will see how to convert the rectangular form to polar form. So suppose I have 1 plus 1j. 1j or 1i also you can use. So this can be written as 1 plus j. Okay, or 1 plus I. Because it is 1j, I have written it as j. Now I want to convert this to polar form. That is, I want to know what will be the magnitude and the angle. I will find out the angle first in the form of degrees. Later on we'll see in the radians. So now first you have to go to the mode. You have to change the mode to complex. Then again go to the mode and choose whether you want the angle in degrees or you want the angle in radians. So here I want the angle in degrees. I will press on 1. Okay, now it is set. Now we want to find out the angle for 1 plus j. So what I'll do is 1 plus, here you have I, that is at this point you have I, at eng is there, no, here you have a I, press on this, so here you will get I. Now press shift and here at this plus sign you can see you have R angle of theta. It means it will give you magnitude and angle. Now press this R, sorry, plus sign and equal to. So this is our magnitude, that is 1.44 is the magnitude. Now I want the angle. Again press shift and equal to. This is our angle. So what is our magnitude? Magnitude is 1.414 and angle is 45. I will take another example. Suppose I have minus 4 plus 4j. I want to find out the angle and magnitude for this. Now again, already the calculator is set in the complex mode and we want the angle in degrees. So we have set it into degrees. Minus 4 plus 4i. Okay, you have to type it as, or you have to press 4 first then I. If you press I first then next 4, it will give you a error. Now go to plus sign equal to. This is our magnitude. Again shift equal to. This is our angle. Now suppose you want the angle in radians. Again go to the mode. Change the mode here. Press 2. Okay. Now minus 4 plus 4i, shift plus equal to. Magnitude will be same. Shift equal to. So this is our angle in radians. Previously in degrees we got it as 135, but here in radians we are getting it as 356. So this is how you have to convert the rectangular form to polar form. Thank you. So you have seen here how to convert the rectangular form into polar form in order to get the magnitude and the angle. Now we will see the program. So here what we will do, we will give the input signal. Okay, then we will compute the DFT. Okay, then display the DFT. After that we will find out the magnitude and we'll display it. We'll find out the phase, we'll display it, and we will plot the magnitude and we'll plot the phase. So this is a simple flowchart for the program. We'll start. First we'll clear the command window and the workspace. Then we'll take the input x, that is we'll take some sequence from the user, and we'll calculate the length of x, that is n or n1 we'll take. Then we'll compute the FFT. Okay, so here it is compute FFT of x, that is capital X is equal to FFT of small x. Then display capital X, magnitude and phase, and plot the magnitude spectrum, plot the phase spectrum, and we'll end the program. Okay. So here the first command is CLC, then which clears the command window. Then we have clear all, which removes all the variables from the memory. Then we have close all, which closes all open figure windows. Okay. Now next we have x is equal to input, enter x is equal to. So always the commands here, it should end with the semicolon, and here you have like this instruction or this command. Here the user will enter a sequence, okay, x. Then next is n1 is equal to length of x, that is it will calculate or it will store the number of elements in the x, that is a sequence. Next you have to compute the FFT of the input sequence by using capital X is equal to FFT of small x. So the fast Fourier transform, it is used to compute the discrete Fourier transform of x. Now this will result into capital X, which contains the complex values. Now you have to display the results. So for displaying the results, we are using display small x is equal to, that is here we'll get the sequence which we are entering. Then display capital X. Okay, capital X is nothing but our FFT, that is nothing but the DFT of x. Then we have to display the magnitude, okay, and we want to get the absolute value of the magnitude here. So ABS of x, it gives the magnitude spectrum. Then we have display phase, okay. Then we have display angle of x, which will display the angle. Now we have to plot these. Okay, we have taken 2 rows, 1 column. Okay, sorry. Here we have 2 rows and 1 column, and this, it must be displayed in the first quadrant. Fine. So here next we have this is for plotting the magnitude spectrum. Okay, subplot 2 comma 1 comma 1, it is to plot the magnitude spectrum, and we have k is equal to 1 colon n1. Then we have stem k bracket k comma absolute value of, that is absolute of x. Okay, so here this subplot 2 comma 1 comma 1, it creates a subplot with 2 rows, 1 column, and selects the first plot. Then stem stem k comma absolute of x, here it will plot the magnitude using a stem plot. Then we have title of magnitude of x of k, then comma we have color comma r. Okay, this will set the title in red color. You can change this, you can change this to B, which will give you blue color, or G, which will give you green color. Then we have grid on, okay, which will enable the grid for better visualizations. Then this is for plotting the phase spectrum. That is subplot 2 comma 1 comma 2. So here this will select the second quadrant or the second subplot, and it will plot the phase spectrum using the stem plot. And this filled option, it fills the markers, and here we are using the again red color, so it will set the title in the red color. Okay, now input will give it as 2468, which I have shown in the problem, and output you should get like this, that is x is equal to, we got it as 20. Initially it was you were not having any imaginary term here, you got just 20 there. Then minus 4 plus 4 I, minus 4 plus 0 I, that is it is only minus 4, and here it is minus 4 minus 4 I. Okay, so here you will get magnitude as this, that is for 20, for this term you are getting magnitude as plus 20. For this minus 4 plus 4i, you are getting it as 5.6569. For the third one 4 and for last one you will get 5.6569. Similarly, this will be the phase which we have calculated. I have shown you. Now we will see the this you will get as the spectrum. Sorry, uh, in the figure window you will get, that is first row, second row. Okay, we have taken two rows, one column. So magnitude is in the first subplot and phase it is in the second subplot. Okay, so here what we have done for to calculate or to find the DFT of the given sequence, here we have entered the input sequence X, then we have calculated the FFT in order to calculate this X. Okay, that is the DFT of the given sequence. Then we have displayed the results by using these, that is display X will display the magnitude, will display the phase. That is, we are displaying the input sequence, we are displaying magnitude, we are displaying phase. Then later on we are plotting this, that is if we want to visualize the data of the magnitude and the phase, so we are plotting the magnitude and we are plotting the phase. Okay, now we'll open our MATLAB software. Okay, open this. So here you have the command window, you have to write the program in the editor window. I will open the program, already I have saved it by a name DFT. Okay, here. Okay, this is my editor window, this is the command window where I'll see the output, and here you have to type your program. Already I have typed the program and I have saved it. Always you have to save the program in MATLAB by .yum extension. Okay, now I will run this. Here you have the run icon, click on this. Click on the change folder. Now you have to enter the sequence. Carefully see how I enter the sequence. Square bracket, opening square bracket, 2 space 4 space 6 space 8 and close the square bracket. Now enter. So here this is what you are getting, that is X is equal to, I'll show you here. Okay, X is equal to 20. Okay, 20 plus 0, 0i, minus 4 plus 4i. Then you have minus 4, minus 4, minus 4i. So same thing you are getting here, that is 20 plus 0i. Okay, this one here. Then minus 4 plus 4i, minus 4 and minus 4 minus 4i. For that you are getting the magnitude as 20, 5.6569, 4, 5.6569. Similarly phase, for this 20 magnitude, phase is 0. For this you have 2.3562. For 4 you have 3.1416, and for this last one you have minus 2.3562. Now this must be plotted in a graph. So here we have the figure window. Now you can see here, this is the magnitude. Here magnitude title we have taken the color as red, so we are getting it in red. Here phase also we have taken the color as red, so we are getting it as red. And the title is magnitude of x of k, so magnitude of x of k. Then here phase of x of k, so phase of x of k. Fine. Now here you can see this is the magnitude. Okay, now the first magnitude is 20, so at here. Okay, here you are getting it as 20, that is first position. Second, third and fourth, we are having 4-point DFT. Okay, second is what? Second is minus 4. Okay, sorry, magnitude is 5.6569. So magnitude here it is around 5.6569. Then we have magnitude 4. So here at third point we are getting it as 4. Then at fourth point we are getting it as 5.6569. Similarly, we have phase. Phase, first it is 0 here at 1. Then at 2 it is 2.3562. So it is around 2.3562. And here at third position we have 3.14. So here 3.14. And here last one is minus 2.3562. So minus 2.3562. So this is how you calculate the n-point DFT, and you have to plot the magnitude and phase spectrum for the n-point DFT. Hope you have understood the program and the problem. Thank you.